Numerical number 5.10, rather example of the 5th chapter. Solenoid has a core of material with a relative permeability 400. The winding of the solenoid are insulated from the core and carry the current of 2 ampere. If the number of turns per meter are 1000, or we can say number of turns per unit length is given, it is n is equal to 1000 per meter. We want to calculate these quantities H, M, that is, and B, and the magnetizing current, that is Im. Now see, the solenoid, when there is nothing kept inside, then there is a vacuum, and when you place some core, then its magnetization changes. Okay, that part we are understanding here. Okay, now see, here H is dependent on the material of the core. Okay, now inside the, what you call it, solenoid, you are keeping something, means some core you are placing inside. Okay, and as you know, we have this formula H is equal to N into I, so we can just place the value of N and I which we are passing through the solenoid, then it becomes 2000 ampere per meter. Now as you know, B is equal to mu into H and mu is equal to mu 0 into mu R. So instead of mu we can write mu 0 mu R. So it becomes B is equal to mu 0 mu R into H. It becomes, okay, all the values are with you, just we have to place those values and we get magnetic field when the core is present. Try to understand, when the core is present inside the solenoid, some material is placed inside the solenoid, the magnetic field is 1 Tesla. Okay. Now, as you have M is equal to B upon mu 0 minus H, we can take mu 0 as LCM, so we can have B minus mu 0 H upon mu 0. And instead of this B, we can write mu 0 mu R into H. So we have written it here, mu 0 mu R into H, and mu 0 can be taken common and it can be cancelled out. Okay, here this can be taken common and it gets cancelled with the denominator which is having mu 0. So we have M is equal to H is taken common, mu R minus 1, H is with you, okay, 2000, or we can say 2 into 10 raised to 3. And mu R is 400 minus 1. Okay, 400 minus 1 is approximately 400 only. We can just multiply it with 2 and you get approximately 800 into 10 raised to 3 ampere per meter. Okay, so all these values we got. Now, to produce the magnetic field of 1 Tesla, now say for example you have this solenoid which is having some core within it, and because of that you are producing the magnetic field of 1 Tesla by passing say 2 ampere current. Try to understand. Okay, to produce now magnetic field of 1 Tesla without core, now you are removing this core, okay, inside the solenoid, we require the additional current. Okay, because earlier, because of the presence of the core, only with the help of 2 ampere current you were able to magnetize, or you were able to find the magnetic field of 2 Tesla, rather 1 Tesla. Okay, now additional current is required and that current is Im. Now originally current in the solenoid, that was 2 ampere. So now total current will become 2 plus the additional current Im. So it becomes B is equal to magnetic field inside the solenoid is B is equal to mu 0 Ni, but instead of I we write I plus additional current Im. Mu 0 is known to you, B is 1 Tesla, N is known to you, okay, 1000, and I, that current which was earlier flowing is 2 ampere, this is 2 ampere. Now this Im can be easily calculated. Okay, thank you very much. Now example 5.11, a domain in the ferromagnetic iron is in the form of a cube, okay, of side which is having 1 micrometer length. 1 micrometer length means 1 into 10 raised to minus 6 meter, okay. Estimate the number of iron atoms in the domain and maximum possible dipole moment and magnetization of the domain. The atomic mass is 55 gram per mole and density is 7.9 gram per centimeter cube. Assume that each iron atom is having the dipole moment of this much, okay. Just we have to use our original the knowledge of the atomic mass and all, okay. Now see, the volume first of all is found. Volume is 10 to the volume is L cube, so 10 to the power minus 6 raised to 3, so it becomes 10 to the power minus 18 meter cube. And if you want to convert it into centimeter cube, then we have to multiply by 10 raised to 6. So it becomes 10 to the power minus 12 centimeter cube. Why? Because the density is given in gram per centimeter cube. Now mass of that particular domain, mass is the thing, but density multiplied by volume, okay. Density is known to you, volume we have 10 to the power minus 12, so we get the value of mass, okay. Now atomic mass is given 55 gram per mole. It means 55 gram will have 1 mole of atom, that is 6.02 into 10 to the power 23. So the mass which we have, that of a domain, is 7.9 into 10 to the power minus 12. How many molecules will be there? So just a cross multiplication and divide it by 55, and that will give you the number of atoms in the domain, that is 8.65, okay, into 10 to the power 10 atoms, okay. Now each atom is having magnetic dipole moment to be 9.27 10 to the power minus 24. So these many atoms in the domain will have how much magnetic moment. So we just have to take the multiplication. So this will be the maximum magnetic moment which can be produced, or which can a domain have, okay. Now magnetization is nothing but maximum magnetic dipole moment per unit volume, so you just divide by volume, okay. So maximum dipole moment we got 8 into 10 to the power minus 13 ampere meter square, and divide the value by the volume of the domain, and you will get the magnetization, that is maximum dipole moment per unit volume, okay. Thank you. Try to calculate all the numericals and illustration 2-3 times in notebook.